The future of computing isn't just faster, it's fundamentally different. Quantum computing promises to transform how we solve complex problems, from portfolio optimization to fraud detection. But if that power remains locked away in research labs, what's the point? What does it really take to democratize quantum computing? How can financial institutions practically benefit from quantum-powered AI? What role does the cloud play in unlocking this potential? And are we ready for the talent crunch that's coming in this space? Dipen Mehta, head of financial services at SoftServe, is joining us on ATP to break it all down. Let's talk about quantum computing. How is quantum computing different from our current computing platforms?
So obviously, there's one major difference, which is it's based on the kind of, if you like, the laws of quantum mechanics. And so when you think about classical computers, we have bits and bytes, but let's focus on bits for a second. So these are effectively, binary numbers. They have a value of either 0 or 1,
Yep.
And then you kind of combine them to do some sort of outcome. And in quantum computing, you still have the 0 or 1, but this notion of qubits or quantum bits, known as qubits, can actually have a state of anywhere between 0 and 1. And so in fact, they can kind of exist simultaneously in multiple states between 0 and 1. And so depending on when you observe it, it can be any number effectively or any probability between 0 and 1. And so this is quite a hard concept to grasp fundamentally, but this sort of like superposition, as they call it, allows you then to observe things in parallel. So you can actually have one qubit in this case, doing multiple kind of things and actually being observed in multiple states.
So again, let me see if I can get this straight. So we still have the 0 and 1, but it can be at any state. It can be at 0, it can be at 1, but it can be also at any state in between them, and it could be in multiple states at the same time. That's right. I'm just trying to go back to my risk management stuff when I was at Morgan Stanley, when I was at Goldman Sachs, and thinking we built all of this stuff to do portfolio management and risk management, but to test and iterate, you had to make a decision. Was it 0 or 1?
That's right.
So go ahead, sorry.
Yeah, so if you think about, that exact, and we'll probably talk about it some more
Please.
Today, but if you think about Monte Carlo simulation, which is sort of like
exactly.
the fundamental kind of
Black-Scholes
algorithm that every major financial institution uses,
right.
That's a very linear, effectively it's a linear
if this
kind of
happens,
outcome.
then that happens.
Right, so you say, okay, the price is X now, tomorrow will be Y.
Right.
Right, and you multiply two numbers and you get a new number. And you did it over and over and over and over and over, and then
right.
you get some sort of probability across that.
Right.
But with quantum now, you don't have to do as many, because you can actually parallelize them within one.
So that's what I was just thinking. Like, it makes your ability to do risk management so much more efficient. And that's just in one place, right? I don't want to spend 100%. All day talking about risk management. But I'm just thinking it must mean that since you can just kind of splash it into a bunch of different states at the same time, you can see a bunch of different outcomes at the same time.
That's right.
And then make a decision.
Kind of monitoring across. And that's where I would say the science comes in, and that's where it starts getting very, very difficult. And we'll talk about some of the challenges around quantum in a second, but that's actually one of the challenges.
So that's what I wanted to ask you. Like, we're not there yet, right? People are not using this yet?
Yeah. So, I would say that we're really early. But at the same time, if you're not paying attention to it now, you're going to miss the boat in many ways, right?
Okay.
So if you really think about where we are now, it's still very scientific. It's, again, going back to quantum mechanics, it's really useful in sort of chemistry, applied materials, some physics kind of simulations. But seeing that real world business benefit, we're not quite there yet, right? And so you can hear, the famous one is, Jensen from NVIDIA said, it's 30 years out. I'm not so sure it's 30 years out. I think that, let's be honest, aside from everything going on with DeepSeek and everything else,
I was just going to say,
NVIDIA is very focused on their current
right, because they don't want you
GPUs,
right. They want you to buy as many of those as humanly possible,
and then when those die out, they'll be building QPUs, as we call it, right? So quantum processing units, and that'll be the next technology, right? But we've seen CPU to GPUs where we are now,
right?
And then we're going to get to QPU. But I think someone like a Jensen's he gets it, right? He's not going to kind of cannibalize his current business, right? It's his cash cow. So I think that's maybe a really pessimistic view. Would I say that by next year we're going to start seeing quantum computers and usefulness in production in financial services? Probably not.
Probably not.
Almost definitely not. But it doesn't mean you shouldn't be investing now. And I think actually what I'd love to talk about a little bit is the convergence of classical computing and quantum computing and see where they're kind of good at different things.
Yep.
And that's probably where we're going to see this sort of hybrid reality take place.
So what does that look like?
So it looks different in different cases, but let's take the Monte Carlo example because that seems to be like the low-hanging fruit. You would think that you can actually do the classical Monte Carlo, like that programming of that individual path in Monte Carlo, and then parallelize that on quantum, right? So you don't have to necessarily try to figure out all the states and kind of observe these qubits, across space and time. You almost like a traditional computer, but you're parallelizing.
Right.
And I think that's going to be this sort of a bit of this hybrid nature. And then similarly, we'll talk, I'm sure, a little bit about AI and where we see AI going.
Yeah.
But AI and quantum, that's going to be a really interesting kind of marriage as well. Right.
Yeah, I'm just trying to think about where that would go. You mentioned DeepSeek, and I can't get this out of my head just because it's been all over the news in the last week or so, right? But you said Jensen Huang said that it's 30 years out. There's no way it's 30 years out. It's like it's always 30 years away until it isn't.
That's right.
And you've seen enough IT cycles and tech cycles to know that like the things that are 30 years out could be 30 days away. And I think that DeepSeek is the perfect proof of that. Are we convinced? Because I was going to ask you, like, who are the people that are furthest along in doing this? I would presume like IBM, Hitachi, some of the big like tech companies.
Yeah, so I would say that if you look at the hyperscalers,
Yep.
all three of them are investing heavily in this space.
For
right?
sure.
So I guess it would start with from a kind of core hardware chip manufacturing. NVIDIA is actually investing a lot in this space. So aside from it being 30 years away,
Right.
we're using their technology as soft serve today, right? And playing with some of their libraries and their tooling in the quantum space.
Oh, really?
AWS obviously
Sure.
has been in the space for a while. Microsoft, Google recently in November, or actually December now, in November, December, they had their Willow chip architecture that came out. So there's a lot of advancements, but it's still really, really, really early days. And I think we talk about why is this so hard?
I was going to ask you.
I would say there's a few different dimensions.
Give me a few.
So first is maturity. So there isn't a single standard.
Right.
In the sense of the hardware.
Right.
And therefore, there isn't a single standard for the software. And I think that's the most important part.
Because that's the other thing I was going to ask you
You
about.
need to be able to write software.
What's the
to run
operating
on this
system?
quantum.
Yeah.
There's different frameworks and there's different,
Right.
kind of evolution of these kind of capabilities. So that's the first one. Then there's, and I think, look, on that one, there's cloud and sort of quantum on cloud, and we can talk about that in a second. Then there's also lack of talent. And that's an area that I think we as SoftServe are really focusing on, which is education. And how do you get trained developers, how do you train business analysts to understand what this is going to be?
So can we go through this though a little bit if you
Yep.
don't mind? So we know at some point, again, just because we've seen so many of these tech cycles, right, that at some level we're not going to be using an Altair and all these other different types of computers. Right now it's like Mac and Windows. That's kind of the best we got for most people.
For most
right?
people.
There are different versions of Unix out there for sure, but to be fair, again, both the Mac operating system and the Windows operating system have a Unix core.
That's right.
Okay. Anyway, so we're gonna devolve into like one or two operating systems. But how can we even start to train people when? And I'm super curious about this, right? Because you're right. You don't want to wait 3 years or 5 years to start training people. But if you don't even know what the operating system is, you don't know what the standard chip is. How are you like? What's the training that you do to get people ready for this?
Yeah. So I think, look, there's a few different things. So we for example, in 2023, SoftServe did the first of its kind boot camp with the IMDA and the National Quantum Computing Infrastructure in Singapore.
Super cool.
And we trained, a bunch of graduate students from NUS and some of the universities in Singapore on this concept. And so it was a multi-day, multi-week kind of boot camp. And it was a mix of theoretical things. So understanding, because ultimately, if you're going to be early, you have to kind of understand
The
quantum
theory.
mechanics
Yeah,
a bit.
yeah.
Then you look at, here are different frameworks and ways to build things. And then let's build a small use case so you can see how it works. Right?
So what kind of use case did you give them?
It depends. So they weren't industry specific. So
Okay.
there were a
Different
couple of
ones.
different low-hanging use cases. But yeah, it's effectively programming something where you can observe a qubit and get a piece of data out of it.
That's kind of cool.
And it's very, it sounds simple, right?
No, it doesn't sound simple at all.
But it's not.
I'm sure it's not at all.
And so I think that's the kind of thing.
But it must
that
have been
people
super
need to-
exciting for the people that were going through that, particularly if they were college or university students.
Yes, and they were just
Graduate
graduated
students,
university students. But even Singapore government, I think if you look at Singapore, I guess in the ecosystem in this part of the world, they're the furthest ahead, right? So they've been investing in quantum since like 2000,
Right.
and so they're putting a lot of money around. They're putting a lot of grants in place to get people to be like the future of this.
Right.
But OCBC just announced in November that they're training 100 people on quantum.
Really?
Right, as aligned to the kind of strategy of Singapore. And I think that's just one example. They went public with it. I'm pretty sure the other banks are going to be right behind them.
Are doing it, yeah.
Right. They're, I would say, DBS is probably already doing it. Maybe they just didn't announce it. And that would be similar to some of the larger organizations as well.
I'm sure your old bank is doing it as well.
Oh, for sure. Yeah.
Is GIC and Temasek and all those guys, are they investing in this? I mean, I don't want any inside information, but they must be pouring a ton of money into this.
A ton of money into it, yep.
Yeah.
And it's not just quantum, right? I mean, think about all
Tons
of this.
tech.
They've been early on GPUs. They're going to be early on GPUs.
What are some of the challenges? You mentioned this before. Like, why is it not stable yet? Why are we far away from this, do you think?
Oh, I mean, why is it not stable? I think it's less...
Because we understand... I'm pointing at myself like I have no idea about quantum mechanics. I should study this, though, right? But quantum mechanics is a well-understood piece of science, no?
Yes, in the real world, it's understood, and then putting that into a physical kind of representation of it that you can do things against is where we're struggling.
Is it just unstable?
It's very unstable. So there's this whole concept of collapsing and a few things that happen within the qubits.
Right.
So there's a lot of errors, basically. If you actually boil it up a little bit, if you think about error correction in traditional computers, ECC, that's the same kind of challenge that people are trying to fix now, which is the quantum error correction kind of mechanics. And so we've been pretty good at 1 qubit, 2 qubits. But if you start going from there, we haven't quite figured out how to, if you'd like, measure the signal-to-noise ratio correctly.
Right. So they're interfering with each other.
That's right. And it's actually, so quantum interference, the 3 main concepts in quantum. Again, I'm not going to go into too much detail here because
it's not a quiz.
I get out of my depth very fast. But we talked about kind of superposition between the 0 and 1.
Right.
There's this notion of entanglement, and this is another area why quantum is so exciting, is that qubits can actually be almost kind of entangled with each other. So if you think about today in computing, it's at best 2-dimensional, sort of 1, 0 or X and Y. With quantum, you can get even like a 3rd dimension, right? So you can start generating these vast structures of data where the qubits are intertwined in all of those states, right? So we have this like really complex data processing platform. And it's exponential. So it's like 2, and then if you got to 3, all of a sudden it's exponential, and you go from there. So it starts getting very complicated. And then the third part of it is this quantum interference where they can collide effectively. And so if you think about a wave, or like in the ocean, you have waves. You have a small wave and maybe a big wave behind it, and it might ride it, and it'll be a bigger wave. Otherwise, they might collapse, and then the wave collapses, right? And it's a small wave. So it's like constructive or destructive interference. And that's the same concept in quantum. So understanding that and then taking advantage of it is actually a good thing. But again, it starts getting exponentially complicated. And I'll probably stop there because that's where it gets very...
I think we could talk about that for hours.
Yeah.
But isn't quantum mechanics as well this thing where if like you're observing it, then you're also impacting it?
That's right.
So we have to figure out... This is one of the things I love about advanced science. I think I learned this to myself, or I taught this to myself like when I was in my early 30s, that science is not invented, it's discovered. That everything on the earth is here for some reason that maybe we don't understand yet. But once we figure it out, we've been really good at trying to use it to create energy, to create power and stuff like that, right? 100%. Like we didn't invent electricity. We discovered it.
That's right.
Yeah, and the same thing with sound waves. And I think quantum is the same thing. And I don't think that's a controversial statement.
No, because that's the real world that we live in.
It's out here. It's going on all the time.
We've manifested things into the ways we understand it.
Exactly.
So that was like classical computing.
Yeah.
So now with quantum, it's like, okay, we understand kind of how it all works. How do you actually leverage the power of it? Right?
So now we have to talk about this in the context of AI, if that's okay with you.
Okay.
Because AI in and of itself, even on our traditional computing platforms, is really powerful. And with the GPUs getting more and more powerful and being able to operate those in parallel, right, and operate at scale, and with all of the throughput that we have now, right? Look, when you were much younger, 56K modems were probably still around. So we weren't
2400. Yeah, old school.
But I mean,
I'm older than I look, maybe. Let's see.
I'm younger than I look, so fair enough. We cancel each other out. But my point is that, like, back then, even if we had the technology to do this, we didn't have the throughput of the compute to be able to figure it out. I mean, to be able to actually run this stuff. But now we do. But if we can kind of harness the power of quantum computing, what is the impact on what it's going to do for something like AI in general? And we can just surmise about this, but I'm sure you've done some work on this, and generative AI in particular.
Yeah, so if you think about, so let's say generative AI, large language models, right? Yep. They're trained on a massive corpus of information.
Right.
We're limited in many ways by just compute capacity as it stands today. So
and it's expensive.
And it's super expensive. That'll have a Moore's law to it anyway, right,
Sure,
at some point.
everything does.
But I think that when you look at it from a quantum perspective, obviously it's not a direct replacement, but the concept we just talked about, there's way more data we can parallel, almost way more data we can have access to and generate. And
but also way more outcome.
Way more parallelism within the compute of that.
Right.
So the training of models should therefore happen much faster.
Right.
I mean, obviously we're DeepSeek's maybe, so new we didn't even work this into this conversation.
No. I don't
some
know
of
enough
those
about
techniques,
it yet. Yeah.
right, have now proven that actually you can break the problem down even further and smaller, and you can train like smaller subsets of these models and make one big one, and that's kind of the DeepSeek approach.
Right.
Who knows how that's going to be affected in quantum, right? Does that mean like you can just train the parts of your model in parallel and it's done like in 1/100th of the time or 1,000th of the time? I think that it's a bit of like, I don't even know yet now because it's all so new. I would say traditionally it would have just been that you have the ability for massively parallelization of that training.
Right.
So you would think that large language model training, traditional, the way we used to do things, would go way, way faster.
Right.
But I think now it's something like distillation and all these techniques that DeepSeek has kind of popularized in the last couple of days almost, right? The last couple of weeks. That'd be really interesting to see how it could be applied to quantum.
So I think, and again, push back where you think I'm wrong here, but I think we're at a point in our current compute environment where it's kind of fast enough. But let me just qualify that. So I'm not concerned so much with the speed that quantum's going to give us, but I am interested in the number of times it can do that speed. Right, so this parallelization that you're talking about means that if I go to Midjourney now, you know what Midjourney is?
Absolutely.
Right, so I go there, create an image. It takes 2 minutes. That's not a long time, really. You could do it in a minute. Maybe you could do it in 5 seconds. But if I have 2 minutes and now it's quantum enabled, I could get 3,000 images in the same 2 minutes. And that's interesting to me because it also means that in medical science as well, if I want to test like a cure for cancer, instead of having to wait 3 minutes or 3 hours for the output, for one output, I can get the same amount of time because I have time. I can get 1,000 of them.
Right. And actually, I was just going to build on that. Great example outside of in another industry, but it's also now that you can effectively kind of reinforcement or retrain the model, realign the model much faster as well.
Yeah.
Right? So it might be, okay, in your Midjourney example, I get more outcomes. But in that, searching for a drug or a new discovery, it's actually, I want to change this parameter, do the whole thing again. And I can just do that rhythm way, way faster than I can today.
Right.
Rather than maybe not just parallelize it, but probably do a bunch of both, right? So parallelize and kind of reiterate. And I think when you think about where we are with large language models is obviously they're always a point in time, right? That's the whole argument about you have to train the model, then you train it again. And that training is not cheap. It's very lengthy in general. So now you might have a future, a quantum-enabled AI future where you're almost retraining almost real time. And then it's, changes a lot of the architecture that people are playing with now.
So if you combine these 3 things together, quantum computing, AI and generative AI, those 2 things together, right, as a package, and then financial services, what does it kind of look like to you when you see this in potential practice, coming out of the theory into potential practice? If you're going to go to some of your clients and say, here's where I think it's going to be most effective or heavily effective for you, what does it look like to them and what does it help them do? Is that fair?
That's fair. I think there's kind of like this nirvana end result. So maybe I'll paint that and then I'll work backwards. What are the things that we might be able to do together now?
Yeah.
Starting now, obviously it's going to still take some years, but I would say that I hate the buzzwords around this, but it's the reality. The nirvana is going to be hyper-personalization, right? And we keep talking about this concept of highly personalized and kind of optimized for you financial services.
Right.
And we've been talking about that since the notion of digital transformation started, well before generative AI.
Yep.
It was just doing analytics to say, okay, Michael looks like this, and so these are some behaviors. And at first it was like pattern driven. Now it's got some more advanced machine learning and AI. Now you have generative AI on top, right? That makes it a little bit more human. I think that with this, if you add quantum into it, it could be, hey, we can reprice your portfolio or reoptimize your portfolio in real time, kind of right when we're talking, right? So it would be a conversation like you could have with your relationship manager, which you can do today now through generative AI, but it can't affect the outcome that fast. I think there's going to be a future where it's like you literally are having banking, what's the right word for it, but talk about, kind of real-time banking, I guess is another terminology for it, but it's like real-time personalized banking for you at the moment you need it.
Right.
And you're interacting with it in human language, in whatever language that is, through generative AI. It's then computing things in the background that it couldn't compute fast enough before, and then making those changes as you're going. Right. And that would be quite an interesting future.
Right.
I think that's where it gets to, right? And so if you peel that back, it's okay, yes, we need to get even better at this sort of human interaction through LLMs, which it's pretty close, but it's only going to get better and better and better, and that's going to happen through quantum.
Yeah. There's
going to be much better, call it portfolio optimization, right, through the techniques we just talked about, right, with Monte Carlo on maybe a single asset, but then a portfolio or a basket of assets, and then there's going to be this ability to set your risk tolerance, basically, real time. I mean, you can't really do that today, right? You might say, okay, I want to go. I'm high risk right now, and then your RM's gone off and done a bunch of stuff, and then maybe in a year when you're reevaluating your performance, you're like, actually that was too risky, or actually I want to go more risk. It's a very slow process. So I can see that, you can get it from an investment side all the way to retail. It can be sort of point of sale. You're buying a dishwasher, and obviously you can get a loan now, right? You can get a point of sale lending, but it could be point of sale lending and then taking into account market movements at that exact period of time. So maybe you say, I want to short that, take that, or I want to exit this position because you just run an analysis on me and we think the stock's going down.
Right.
So I'll get out now, take that difference. Can I borrow against that today, buy that dishwasher? A crazy example, but I just think you're going to be able to connect all the dots that you couldn't connect because you're going to have this power. That's a nirvana end state. I would say...
But definitely possible. Sorry, go ahead.
Yeah, no, I think it's definitely possible. I would say that's maybe not a year away, or it's probably not 30 years away.
No, but you're gonna have to write a lot of software to be able to do that. That's gonna take some time. But I don't think that the compute is gonna be the problem.
That's right. So I think this goes back to those barriers to entry, right? So the barriers to entry is, who do we have right now that knows how to program any of this?
Right.
I mean, you take your traditional quants that you have today in most financial institutions. They know how Monte Carlo works, but they don't know how to do a quantum optimized Monte Carlo. Of course not. Right. So that training is going to be there. Yes, we talk about standardization of the compute and the accessibility of that, but I think that'll happen a lot faster than we think because it's like cloud today, right? We made the shift from on-prem to cloud. A bunch of APIs obfuscated the infrastructure. Why would we ever go back to you building your own quantum computer or buying one for your on-prem? You'll probably just wait for the APIs to be exposed by the hyperscalers, and then you'll start hitting that directly. Yeah. So I think that's going to come. What's missing, I think, the third thing that's missing is that ecosystem play.
What does that mean?
And so if you think about any shift in technology, when it got powerful is when there was a kind of a convergence of in this case, a financial institution, so the end customer, the set of technology providers that are pushing the envelope. It could be the hyperscalers or companies like SoftServe, and then either academia or the startup, which a lot of times born out of academia, pushing the use cases and like kind of using the tech, building the core tech, commercializing it, and then giving it to the institution. So that ecosystem doesn't exist yet, right? I mean, it's only...
No, but it's probably being built. I'm thinking really hard when you're talking like, there must be a team of people at MIT. There must be a team of people at NUS.
Yep.
There have to be people at Todai in Japan that are sitting there thinking, we're getting closer and closer to this. How can we simulate what these solutions are going to look like and start simulating in software what those outcomes are going to be as well? So that when we finally get to a place where, because the more I think about this, the more difficult this problem is to solve, right? Quantum mechanics is hard.
Very hard.
And it's very complex, yeah? And no pun intended, but there are a lot of moving pieces.
Indeed. So actually an interesting one when you talked about AI and quantum convergence. So everyone's looking at how quantum can help AI.
Right.
But what's more recent, and only doing some initial reading on this and don't have myself experience in the space, but is the other way around. And it's how AI is helping quantum.
For sure.
Right. And so it's all about the simulation because you can train a model around how quantum mechanics work.
Right.
That sometimes humans will have some difficulty with.
Sure.
And then you have these fine-tuned models around quantum mechanics that are then running simulations of what the quantum computer might look like.
So are you doing that at SoftServe?
So it's still really early.
I know.
So it's
going to be cool. You want to be in that room when they're doing it, no?
Yeah. I mean, if there's show notes, it would probably pass you some white papers that some of our super smart people in the space are doing at SoftServe. Right. But I think what's interesting about that is the race might not be just that ecosystem. This is me pontificating a little bit, but the race isn't going to be so much about the ecosystem between a financial institution, let's say an academia or startup land, and a provider who can give them the technology. it's probably going to be about who can find the right use cases first. Because let's be clear, quantum doesn't mean we're not going to have classical computers, right? There's always going to be problems. I think there's, at least for the foreseeable future, there's going to be problems that are just simply done on classical computing because that's what they were built for.
Yeah, and they don't need to go away.
They don't need to go away, correct. And they're going to coexist. But not everything that we run today on classical computers is going to be optimized. And I think what most researchers are doing now is trying to figure out what are those use cases, those algorithms that make the most sense to run on quantum. And then I think the race is going to be when you find those, like, actually on the way here, I'm thinking, why hasn't someone, actually I think they have, there's a couple of companies in Singapore as well, but where they're like, oh, we're just going to build a quantum optimized Monte Carlo and it's software as a service, right? You can set your own parameters and Morgan Stanley can use it and, JP Morgan and Goldman, and they're just consuming the quantum mechanics, but they're just sending the parameters and data in and they just, like a SaaS almost offering. Seems like that would be the low-hanging fruit, right? So rather than waiting for banks to catch up and waiting for it to get super productionized, those who really want to play with it now, there are obviously companies doing this, but are they building that one use case? Like, is there just the QMC private limited? I don't know, maybe that's something I might have to go incorporate when I get out of here. But Quantum Monte Carlo private limited in Singapore. That's all.
It's a good idea. Maybe you should leave right now. Yeah, right. You just go do it.
When's this? I'll register before this airs. How's that? Right?
Fair enough. I don't want to tell anybody. Yeah. I promise. So what else is going on?
So I think the one other topic that we didn't talk about is, so there's all these opportunities, of course, right?
Yeah.
But the real threat that I think that a lot of people in financial services, but actually other industries as well, more broadly the community, is the threats.
Yeah.
Right. And I think
because that's what I was thinking.
Yeah. So I mean, the most obvious, so one of the most famous, obviously, kind of algorithms, quantum algorithms, Shor's algorithm, which effectively, if it can be implemented as quantum computers mature, we will break the internet. Right. That's the view. Right. So this will allow us to break basically the encryption that we use across the internet today.
Right.
And so as a financial institution, it's not even about the transport of the data that can be broken. It's how we've stored information on servers and in databases and so on and so forth.
Because the quantum is way too powerful for the encryption because you can run all these sort of parallelized processes and just break the encryption.
Yeah, well, actually, so the specific about it is that classical computers are really bad at, for example, finding prime numbers is the example, right?
Yep.
So if I gave you 221, could you tell me what two prime numbers make up that number? Right. We could do it. It'll be a bit of trial and error, and that's actually the problem. So with classical computers, it's like a linear thing. It's basically trying a bunch of combinations, and it's very difficult. So you have like RSA encryption is what we use across the world, basically across the internet, and SHA-256. So these hashing algorithms, in particular RSA, is based on the fact that prime numbers are very difficult to generate. So it will take more compute capacity than we have in the world today to break that encryption. Makes sense. However, one thing that, Shor, basically the mathematician had realized is that actually quantum computing is actually really good at that. Yeah. And that's that first algorithm that quantum's really good at, which is on prime number generation. So we don't have enough qubits kind of stable right now on a computer, but once we do, it'll be broken. Yeah. Right. And yes, there's this whole thing we can talk about with Bitcoin and blockchain as well, but that's an aside.
Yeah, I was thinking about it, but I wasn't going to bring it up because it's not so relevant for this. But yeah,
I spent a bit of time at a bit of a crypto stint myself, so I could talk about it. But I think we just think about it back for the purpose of this. Financial institutions, what do they need to worry about? Is they need to worry about all their data at some point, right? And the day it happens, it'd probably be worse than like a DeepSeek versus an OpenAI, right? It's going to come in and they're just going to destroy the world.
So this is the other thing that I was thinking of. Are we not convinced? Right, because if I had told you 2 weeks ago that the Chinese were going to release a model called DeepSeek that did all this stuff for like 1/10 the price, or actually 97% less price, you would say I was crazy. But then they just released it.
Yeah. Well, there's another one just released as well.
Well, of course.
DeepSeek,
and I'm not convinced.
Cheaper.
And I'm not a conspiracy theorist at kind of any level, but I'm not convinced that, like you said, the hyperscalers, Meta, Amazon, AWS, all these companies are working feverishly to solve this quantum problem. We don't know how close they are because they're not going to tell us. And you're 100% sure because the next war is not going to get fought on a physical battlefield. It's going to get fought online. And if that's the case, whoever solves the quantum problem is going to solve or cause way more problems. And this is just like, when you understand not how easy it is, but the power of splitting an atom in the 1940s, you can either use it to drop on Hiroshima, which is not nice, or you can have a nuclear power plant, which is super nice because it's very clean energy.
That's right.
It's pretty cheap to produce, and actually it's very safe. So it is actually. We can argue about it, but it's pretty safe.
No, I agree with you. It's that comment is what I would stand behind as well. But obviously, history has shown that we've had some missteps.
Well, because humans are humans, but yeah.
Humans will do that. But I'm totally with you on the nuclear side. Right. I think that's kind of the big threat that's looming. Yep. There's one on the blockchain side, which could wipe out the entire kind of crypto thing, landscape. Yeah. But when they go after a bank and they want to hack the bank's data and they can decrypt everything,
it'll happen faster than.
So I think what I actually believe we're seeing some traction as well as self-serve is the conversation around quantum safe cryptography.
Right.
There's quantum key distribution. So one thing you talked about this earlier, observing a qubit, right? We say it can be in multiple states at one time, but the time you observe it, it's in one state, right?
Right.
You've observed it, and you can collapse it down to just that one state. But without getting into too much of the details, there's obviously observability. As soon as someone observes something, it breaks what you were doing. So you can actually tell that there's a man in the middle or someone has compromised your computation.
Interesting.
So technically in quantum, kind of baked into it, you can tell if someone's hacking or observing or jumping in the middle. So now you have this concept of quantum key distribution where they're trying to share keys and do encryption in the space. Taking that same technology now, applying it to your traditional data is where, unfortunately, everyone's going to have to go to at some point. Whether or not you're going to do it now and how much it costs to do is the question.
Right.
But we're spending some time talking to customers around what it takes to do that. Do you want to do it now or wait, right? And it's going to be an arms race, right? It'll almost be like I hate to say it for our age, but it's going to be a Y2K event. But maybe we're way bigger and actual, an actual problem.
Right, because Y2K actually at the end of the day was not much of a problem.
No, people made a lot of money.
I was there. I spent a lot of time worrying about it. It wasn't a big
especially
deal.
in banking.
Yeah, it wasn't.
But I think here it's going to be once we start seeing momentum on.
So isn't that the first use case then? Instead of the Monte Carlo, the first use case is going to be creating security around quantum. Like we figured out how this works. We're not going to tell anybody, but now we create this secure layer using quantum so that once we release it, it's not like a virus. It's more like an antidote.
Yeah, I think that's fair. I would say that it depends on which lens you're looking at, right? So a lot of customers are like, how do we get value out of quantum now? So we run these workshops. We can do design, strategy workshops all the way out to prototyping a few concepts.
Right.
And that's like that revenue benefit or that top line kind of, can I get benefit? And so the Monte Carlo one would be, I can be more accurate, much faster.
I can run more
simulations and therefore I'm going to win, right? Ideally. But if you look at where the operational side of this or where you want to cost avoid, and that's a benefit, right? But
huge
not
benefit.
everyone, it depends on who's asking the question, right?
Exactly.
The CIO is looking at cost, or the COO wants some cost optimization.
Right.
The CRO or the head of the desk is like, no, I want
to make more
accuracy.
money.
I want to make more money.
Yeah.
So I think that they're both existing right now in parallel, but obviously no one's put a Monte Carlo on quantum into production that I know of anywhere in the world. Actually, I don't think I know of a single organization anywhere in the world that's actually has any production workloads in quantum. However, this concept of should I think about how I'm going to secure my environment for when it does come, and then might as well start now because at some point you're going to have to re-encrypt effectively everything you have, right, and swap keys out and all of the technical bits. So do you start now? But then who's going to fund that, and how do you justify a future that doesn't exist yet, but we know it's really close,
right?
And it's going to be that game, right? If you're a CEO of a company, it's like, well, how much do you want? Oh, I need $100 million just to re-encrypt everything or make it quantum safe.
It's not here yet.
Well, it's not here yet. Can we do it next year?
You're playing defense for an offense that doesn't exist
yet.
Kick
the can down the road. It's very classic. And then that's why I said it's like a Y2K thing. At some point, one of the hyperscalers or NVIDIA or whoever it will be will announce that, we've gone from 2 qubits to whatever, 8.
And then that same guy's going to walk into the other guy's office and be like, can I have my $100 million now?
Yeah, he's like, so when does that launch? That launched in 3 months.
Right.
Cool. How long is it going to take us to fix all our data? 18. Right. Okay. So where do we start? And I think, that'll be an interesting one to watch. We'll see what happens.
Awesome. Dipen Mehta, the Executive Vice President and General Manager for APAC at SoftServe. That was the most fascinating conversation I've had this year. We should do more.
Fantastic.